In this video, we're going to take an introductory look at vectors. All right, so let's talk a little bit about what a vector is. So when we think about vectors, we're just thinking about a collection of things. Technically, we say that a vector is a container object, but that just simply means that it holds things of a certain type. So we could have a vector that has a collection of ints, doubles, strings. So anything from our primitive data types or user-defined types, and these could be user-defined types from the standard template library, or it could be user-defined types that we define ourselves. So we have here a representation of maybe students. We could have a collection of students represented by a vector, maybe a collection of employees or a collection of books, a collection of songs or albums being represented by a vector. So a vector is, whenever we declare it, we have to specify a specific type. So we cannot have like a mix and match of books and CDs and employees, but we'd have a collection of a specific thing, whatever that thing may be. So that's basically what we're talking about when we talk about vectors. It's just a collection of a specific type. Okay, so now that we have a basic definition of what a vector is, let's look at actually visualizing vectors and also defining some of the vocabulary associated with vectors. And what we'll find out is we have some similar vocabulary to whenever we talked about strings. So how do we go about actually declaring a vector and bringing it into existence? So assume that we want to represent maybe rainfall for a 1 week period of time. So we may want to declare a variable, and the way we would declare a vector, and the way we would do that is just use the word vector, and then we could specify the type, and maybe the type is double, so we can have some sort of fractional part there. And then we would actually give it a name. So maybe the name of this vector, since it's going to hold rainfall, is called rainfall. And we'll specify the size here inside of parentheses, and since we want to represent the rainfall for a 1 week period of time, we'll use the value of 7. So this statement here actually creates a vector of type double that's called rainfall, so we can refer to this vector by this name, and it's of size 7. Okay, so here we have the size, and here we have the type, and here we have the name. Okay, so out in memory, we can think about having 7 contiguous or adjacent spaces in memory allocated for 7 doubles. Okay, so each one of these would represent space in memory that could hold a double value. And what we call each one of these little spaces here associated with our vector is an element. Okay, so we have 7 elements in this particular vector. And the other thing associated with this vector is, or at least each one of the elements, is what we call an index value. So the very first element has an index value of 0. So we'll just put 0 here, and maybe I'll say that this is the index. So we have 0, 1, 2, 3, 4, 5, and 6. So these are just simply labeling the positions. It's the exact same concept that we have with our strings when we were labeling the positions of the characters in that string. So in our case, if we're talking about rainfall, and maybe we want to represent this rainfall in centimeters, we may have 2.3 centimeters the first day, 1.2, then maybe 0 on the next day, and we have 3 centimeters, maybe 4.2, maybe 1.1, and then finally we have some sort of downpour on the last day, and maybe it's 9.8 centimeters. So this is the collection of data that we're wanting to represent in this particular vector. And we can make use of this particular vector and access any one of our elements at any point in time. So we can have direct access to any particular value in this vector. And the way we do that is just via the name of the vector. So in this case, rainfall. And then in square brackets, we would specify the index value. So if we wanted to access the 4th element, so this would be considered the 4th element in our vector, but it's the index value, that element has the index value of 3. So we would say the rainfall for the 4th day with the index value of 3 would be, we would be able to retrieve that through the statement or this expression rainfall, open square bracket, and then the index value of 3, close square bracket. So this is some of the basic terminology and how we'd go about visualizing vectors in general. And again, these vectors can hold any particular type, so it doesn't have to just be a double or a string or an int or a float. It could be any defined type that we have. So let's go ahead and go over to Eclipse, and we'll take a further look at vectors and some of the syntax associated with using vectors. Okay, so I don't have a specific problem statement here for program 8. That's what we're going to call this program. But mainly I want to just show you some syntax related to vectors and also some of the operations. So let's go ahead and get started and do our pound include. So we'll do a pound include for IOStream. We're going to make use of cout, and we'll also do a pound include. This is a new pound include, but it hopefully will make sense for vector. Okay, so our standard template library is what's providing us with support for this vector construct. And we'll also do using namespace standard. And then we'll get started with our main function. So int main open paren, open brace, close brace. And here we'll actually go about creating our vector with the syntax that we saw before. So just simply the word vector, open angle bracket, it should automatically insert a closed angle bracket. Then you specify the type, and we'll say the type here is just int, and then make a space after that closed angle bracket, and we'll call this vector just v. You could name it anything, but we'll just say v for vector. Open parentheses, and then we'll specify the size. So the size of the vector goes in the parentheses here, and we'll say the size of it is 3. So a fairly small vector. And as it is right now, whenever this vector is created out in memory, it will actually initialize each one of those elements to the value of 0 if we're talking about a numeric type. So if we wanted to change those particular element values to something else, we could specify a particular element, do v, open square bracket, and it should automatically insert a closed square bracket. If we wanted to change, say, the first element, we would specify 0 there as the index, and then use our assignment operator, and maybe we put the value of 10 there in the first element. And we could do that for the second element. So we'll do that. Maybe we'll use the value of 22. And then the third element, which would have the index value of 2. And we'll say that it has a value of 5. So we now have changed each one of our elements to a different value beyond or besides what was there by default, which was 0. Now, one of the operations associated with vectors is that we can actually dynamically add more elements to our vector, which is really nice because there's other container objects that are supported by C++ that doesn't allow you to dynamically change the size of it. So the way that we can do that, say we wanted to add another element onto the end, we could do this. We could do v and then do dot. And you may get a little pop-up list or drop-down list there. It's for code completion. And I'm going to start typing in, push. And if you want to, you can just select push back there. And then you can select what value that you want to have placed in that last element. So this is actually a value that you're going to have placed there. So I'm going to put the value of 7. So that's going to be in the fourth element, the index value, or the element with the index value of 3. Okay, and maybe we'll do some cout operations. So we'll do cout, and we can do v dot. I'm going to just make use of another operation that's available to us, and I'm going to use what's called front. So that will retrieve the value from the very first element, the one that's in the front. So it should be retrieving the value of 10. And I'm going to do an indel, and then I'll do another cout. And as you can imagine, if there's a front, there's also a back. So we can select that. So there's no arguments being specified there for front or back. It's just, depending on how large our vector is, the back will just simply retrieve the value there that's in the very last element, and the front will retrieve the value that's in the very front element. And we can also specify, directly what element we want to maybe print out. So we can do a cout, and then we can do v dot at, which is similar to what we did when we were talking about strings, the add operation. So now it's associated with the vectors. And maybe we want to specify 2 here for the that would actually be, I guess, the third element, right? So it's the vector that has the index value of 2. All right, so we have that, and I'm going to just do a return 0 here. And we'll go ahead and save this, and then we'll build it, see if we get any error messages. It looks like everything compiled and linked okay, and now we'll run it and see what happens. So we got 10, 7, and 5 outputted. So 10 was in the front, 7 was in the back because we did this push back operation here, so that's what we expected. And then 5 is what we expected to get from this operation here. It was the third element, but with the index value of 2. So again, whenever we use the add operation, we are specifying the index value. Let's do one more thing here, and we'll make it a fairly short function. We'll write another function that allows us to maybe print out the contents of our vector. So instead of us having to actually go through and specify every single element here line by line, if we had 100 elements, it would take a long time for us to actually write out a bunch of cout operations like we did here for every single element. So what we're going to do is write a function that will actually print out each one of those values. So this is going to be a void returning function, and we'll just call it maybe print vector. And we'll pass to it a vector that's of type int, since we're vector v is of type int. And it really doesn't matter what you name it. You could name it v, you could name it, I don't know, I'll name it b, just to name it something different, just to show you that we can have it named something different than what we had here before. And we'll simply do a for loop. So for int I, assignment statement 0, so this is our initial statement. We're just initializing that counter called I. And we'll say as long as I is less than, and we have the size operation, so we can do v dot size here. Well, not v, I should have said b. Do b dot size. It doesn't know what v is. So b dot size. Maybe that was a bad choice. B's and v's sound a lot alike. So b is in Bob, and then we'll do I++. So again, just looking at our for loop header, we have our initial statement here that's simply declaring a counter. We have our loop continuation condition. So this is basically specifying that we will keep looping through the body of this for loop as long as I is less than the size, which in our case right now, our vector size is 4. So we should make 4 iterations through this loop body. And each time we go through the loop body, we need to be incrementing that counter. If we don't increment that counter, then we'll set ourselves up where we would be infinitely going through this for loop body. So we'll do cout, and then we'll specify that we want to print out the contents. So we do that by specifying, again, I keep writing b, the name of the vector, and then whatever the index value is in between the open square bracket, close square bracket. And then we'll, I guess, separate out each one of these values with a pipe symbol. So we'll use the pipe. So that should be just shift and your backslash key. That's the case on most keyboards. And make sure you add in a semicolon. One thing that I'll note here is that whenever we call this particular function, so down here I'm going to call this function print vector, and we'll pass it v. What's happening is we actually get a copy of the vector v being passed up here to print vector. Now, is that really needed? Probably not. I think in the next video we will actually look at the various types of parameter passing that we have available to us in C++. And we'll find out that in cases like this, we can just simply pass a reference to that vector v up here to this b. And the b will just now be an alias as opposed to just holding a brand new copy of a new vector. All right, maybe the other thing that we'll do, right now we'll have a pipe symbol after every single value that we print out, but if you wanted to have a pipe symbol at the very beginning, you may want to do this cout, and then just put the pipe symbol there before the for loop, and that'll ensure that you have a pipe symbol at the very beginning. So let's go ahead and save this program once again and build it. And we have some mistakes here. What did I do here? Expected semicolon before, oh, I forgot to do a semicolon after my cout statement. Okay, let's try building that once more. Okay, so you got past all of our errors. It did provide a warning here, or an output, a warning. It says comparison between signed and unsigned integer expression. So this is related to the size operation here. So the size operation isn't actually returning an int value, but it's trying to compare it to an int value. So again, you could do a cast operation there and cast that to an int, but I'm going to just ignore that for now. It's not really important that we change that. So we've got everything building okay, and now I run this program and we get what we had before, but we also get the contents of our vector actually being printed out. So that's pretty much it. A little bit about vectors, and we'll probably come back and discuss vectors in much more detail and maybe have a full problem statement related to vectors and how we can use them.